So in the last sections, we went over an overview of VPCs and subnetting. In this section, we'll actually set up the subnets and VPCs in AWS. So right now I'm here on the home page of the console of AWS, and to access the VPC dashboard, we go to services under networking and content delivery. The first option is VPC. So you can go ahead and click on that. And here we are on the VPC dashboard. So you see the launch VPC wizard at the top, and setting up a VPC using this method, the VPC wizard, is a little bit easier, but I'll show you how to do it completely from scratch. And this way is slightly more difficult, but it will really show you how to set up a VPC in depth. So let's click on the VPCs tab, and then we'll click on the Create VPC button. So just give it a basic name. I'll just call mine VPC3. And for the IPv4 CIDR block, we'll do 10.1.0.0/16. And remember from the subnets overview section, 10.11.0.0/16 means we have the last two octets available as IP addresses. 10.11 is a network prefix, and those are unchanging. We can't do anything to them. 0.0.0, the last two octets, we can make it any number between 0 and 255. So remember that from our subnet overview. And if you're unsure, you skip that section, just go back and I explain in great detail how this IPv4 CIDR block works. We can leave IPv6 CIDR block to none. It's not really necessary for this demonstration. And for tenancy, we can just leave it to default. We don't need to do dedicated. And just quickly, tenancy just means the underlying hardware of our cloud computing VPC. So as you know, cloud computing, there has to be actual servers somewhere in a data warehouse. So tenancy just means the physical computer that's in that warehouse. So dedicated means that there's a dedicated physical computer for our VPC. And there's a perception that if you have a dedicated physical hardware, that this somehow makes your app more secure or more performant, but there hasn't been any data to suggest this. Default, on the other hand, just means we share physical hardware with other AWS users. So our VPC is separate, of course, through software, but we just share certain hardware with other AWS users. And there isn't really a huge performance or security issue with this. AWS is very smart, and they know how to make our VPC completely isolated from other AWS users, even though we are using the same hardware as them. So after this, we can just hit the create button. And that's really it. This is all we have to do to create a VPC. And now we can see it here listed with our other VPCs. And remember, we're using VPC3 for this demonstration. And after creating our VPC, we can now create our subnets for this VPC. So let's click on the subnets tab. Then we can hit the create subnet button. So let's first create a public subnet, because as you may recall, we're going to build a VPC with a private and public subnet. The public subnet will contain our web server, which can be accessed by all the users on the internet, and we'll also need a private subnet that will house our database. And for obvious reasons, we don't want our database to be accessible by everyone over the internet. So this is why we'll have a public and private subnet. So we'll call our first public subnet React Full Stack Public 1. And then go ahead and select the VPC we just created for the VPC option. And then VPC CIDRs will just remain the same. And we don't need a preference for the availability zone. And then here we'll set up our IPv4 CIDR block. And it will be 10.11.1.0/24. Remember, /24 means we have only the last octet available as IP addresses. So when we deploy our server here, it will have a private IP address that is 10.11.1. anything between 0 and 255. So unlike our main VPC, that is 10.11.0.0/16. And the 10.11 is the network prefix and unchangeable. For our subnet public 1, 10.11.1 is the entire network prefix and cannot be changed. So the 0.1 after the 0.11 is the network prefix as well for our subnet, which means it is unchanging. And the 0.1 identifies our public 1. And we'll see this when we set up our private subnet, which will be 0.2. So we're actually done setting up the public subnet, and we can just hit create. And you can see our newly created subnet here listed among all the other subnets. So let's go ahead and create a private subnet. So we'll call it React Full Stack Private 1. And of course, remember to associate the VPC 3 for the VPC. And of course, we have our main VPC CIDRs, which is 10.11.0.0/16. So availability zone for a private subnet for our database, we do need to specify. So we can just use US East 1B. And we'll see this in a second when we set up our database, why having an availability zone is important. And then for the IPv4 CIDR block, we'll do 10.11.2.0/24. So again, 10.11.2 is the entire network prefix, and it identifies our private subnet as opposed to our public subnet. So our public subnet was 10.11.1.0, and our private subnet is 10.11.2.0. So the third octet is important. It is what allows us to distinguish between our different subnets. And again, this is because /24 means only our last octet is available, and that this is what determines the network prefix. And after this, we can go ahead and click create, and then we'll need another private subnet because AWS requires that databases have 2 subnets available. So we'll do full stack private to same VPC, and then availability zone. Make this different than what we set in the first private subnet. And this is important. Our first private subnet was in availability zone US East 1F, 1B, and we'll make this one US East 1F. And I think you can guess what our IPv4 CIDR block is going to be. It's 10.11.3.0/24. Again, the third octet is what distinguishes between our different subnets. So another way to think about this is, well, how do we know our private subnet 1 from a private subnet 2? And it's that third octet, 0.3. That's what's saying this is a different subnet from our first private subnet, which had a 0.2 for the third octet. So we can go ahead and click create, and we're done setting up our private and public subnets. So to make a subnet public, we actually need an internet gateway. So we can click on the Internet Gateways tab and click Create Internet Gateway. And since all internet gateways function in the same way, the only thing we need to do is specify a name for our gateway. And we can just call this React Full Stack. So we see our React Full Stack Internet Gateway here with our other internet gateways. And you can see the state is detached right now. To attach it, we actually need to create a route table first. And you want to think of route tables as a virtualized router. So the same router you have at home, it's virtualized here in our cloud computing AWS platform. So we can go ahead and go on the route tables tab and click create route table. So let's go ahead and name our route table React Full Stack Public 1, and then let's select our VPC 3. So this is going to be a route table for our public subnet, and we'll configure it in a second. Let's just first create it, and you can see this route table is now listed here. And now let's associate our internet gateway. So let's go to the Internet Gateways tab, and then we'll select our React Full Stack and then click on the Actions tab. And then here we'll do Attach to VPC, and then for the VPC option, just select VPC 3, and then just click Attach. Once attached, we can now add this Internet Gateway and associated routes to our route table. So let's go back to our Routes table tab, and then React Full Stack Public 1, and then we'll do Edit Routes. So we'll click on Edit Routes, and we have an Add Route option. So let's go ahead and click that, and then for target, we'll do our Internet Gateway. So this is basically saying that every route that is not local will be routed to the Internet Gateway. So as you can see, our first route is 10.11.0.0/16, and the target is local, meaning these are local routes. So when a route has 10.11, it's routed to our local VPC and local computers. But if it's anything other than that, 0.0.0.0, then it's routed to the Internet Gateway, which then routes it out of our VPC and into the actual internet. and then we can just click Save Routes. So we're not quite done yet. We still have to associate our subnets with this route table. So let's go on Edit Subnet Associations. Then we have this table here with all of our subnets. And we only want to associate the public subnet because this subnet contains an internet gateway. So we'll just select React Full Stack Public 1 and then click Save. And we can't forget our private subnets because we still need a route table for them as well. So let's create another route table called React Full Stack Private. And then for subnet associations, we'll do React Full Stack Private 1 and React Full Stack Private 2. Because again, these private subnets should not be in our public route table association, since that route table has an internet gateway and we do not want this for our private subnets. So we can go ahead and click Save. And finally, we need to set up a security group for our web server. So let's click on the Security Groups tab and click Security Group. And under the Create Security Group tab, we see AWS gives us a nice summary of what a security group is. So it's basically a virtual firewall, and it controls the inbound and outbound traffic. So this is exactly the same as the firewall you have at home. In our AWS VPC, it's simply virtualized. So for the security group name, we'll do React Full Stack Web SG. So the web server security group. And remember to associate it with our VPC3 that we've been using so far. And then we can click Create. Now let's click on this security group. And then under the Inbound Rules tab, we'll do Edit Rules. So we'll keep it simple for now, and we'll need 3 rules. We'll need SSH to remotely connect to our web server. We'll need HTTP and HTTPS. So SSH, if you don't know, it's Secure Shell Login, and it allows us to connect to our web server from our remote computer at home. And then it's always on port 22, and it's source custom. And under the IP address, you want to put your IP address. For privacy and security reasons, I'm not going to put my IP address here right now. But if you're setting this up, remember under the source, make sure you put your IP address at home. And if you're in a home network, your IP address is probably going to be whatever your public IP address is, and then /32 or 31. You can try it out and see if it works for you. But you do need the slash. You can't just put just your IP address. And then we also have HTTP and HTTPS. These are the exact same protocols that you use to access the internet every day. And it's going to be on port 80, and it's always on port 80. And then the source is going to be 000, because again, we want all of the internet to be able to connect to our web servers. And the same with HTTPS. It's the same thing, except you can use SSL with HTTP. And the same with this, it's going to allow every source. And you see we have IPv4 and we have a comma ::/0. So we have IPv4 and IPv6. That's what the comma ::/0 is. So this again allows all IPv4 traffic and all IPv6 traffic as well. And since this is our public subnet that has our web server, we want everyone to be able to connect to our web server and website. So this is how we do it. And then we can just click Save Rules. So that's it. We've completed a basic setup for now. We'll continue building on this in the next sections. And we can leave outbound rules to all traffic. It doesn't matter if we send out traffic to anyone's. There's no risk to us at all. And for this reason, we can just leave all traffic as the outbound rules.